Yara is a powerful tool used in malware research and detection. It allows us to create rules and patterns to identify strains of malware. So let's get started and see how to extract strings and other IOC information from the binary files for detection of the IOCs or the indicators of compromise. Now, likewise, others, Yara has reserved keywords which can be used within the language. Here are some keywords which can be used in the construct of the rules and otherwise for comparison of values and defining the variables. As a simple construct of the rule structure, we use rule as a keyword to start the rule definition, followed by the rule name and curly open brace. Now, string section allows us to define variables where each variable starts using the dollar symbol and assignment of the value happens using the equal to symbol. Let's look at some of the examples. So if we want to match the encoded strings, we need to include the necessary algorithm. So what we see here is we have included a base 64 algorithm which matches up to the base 64 encoded string as given below in the example. As in second example, if we want to make a case insensitive search, we can include a keyword no case at the end of the variable assignment, like we have done in this particular case. In the third example, what we see here is inclusion of a wide modifier which can be used to search for the strings encoded with 2 bytes per character, something typical in many executable binaries that we have seen. Now, coming to the condition block, we usually match the rules defined in the string section here, though we can do more here as well, as we will see in this demonstration. Some of the examples of condition matching includes doing logical matching with and or not keywords. What we see here on the screen is $A or $B, so either of the condition is true, and a $C or a $D, which means either of the condition between C or D should be true. So if we have A or B and C or D, the result will come to be true and hence the rule will match. As in second example, what we see here is usage of all, any, or some of the variables defined above. So we can say all of them, any one of them, or any of them. All of starting with a $A asterisk mark, which is a greedy identifier, and then any of $A, B, or C, and then one of any of the variables defined above, so which is as good as any of them. So this is just a classic example of how the conditions can be matched here. Another example is doing a file size comparison. So we don't have to include any specific module here. We can just say file size greater than the number and the human readable format of the size. So that's perfectly fine. And after that, we take an example of matching the condition at an offset. So we have in this example a dummy1 and a dummy2 as two strings. And what we are specifying is that dummy1 at a location 100 and dummy2 at a location of 200. So if it matches the rule and hence the true condition. Also, we can count the occurrences of the defined variables in the file. So we can say if the dummy1 in the above example has an occurrence of 6 times, or if dummy2 happens to be in the file for more than 10 times, then the rule is said to be set. Enough of the theory. Let's look at all of this in action now. Alright, so here we are on the black screen. What I have right now here is some grep patterns file, some notepad.exe file, and satin.bin, which is a ransomware file. Now what we are going to look at usage of the Yara rules on this Unix. But before we do that, we need to extract the strings, which is nothing but the indicators of compromise. And the way we do it is using the strings command on Unix. So the way we do is strings and then give the file from where we want to extract the strings, the ASCII strings. Now if we do pipe it to more, we see that there are some ASCII strings which is getting pushed to the screen, but it may or may not make sense to us. So essentially what we need to do now is we need to make sure that we are reading the right things, and what we want to do is we need to grep the indicators of compromise that we are interested in, and we are going to read it from the grep patterns that we have. In a while I'll show you what grep patterns look like. So sorry, my bad. And then here we go. Now what we see here is based on the pattern, there are certain ASCII characters which has got printed on the screen. So we have, all you have is a pawn, common sense is so rare, Laplace figure problem, and so on and so forth, which may or may not relate to the indicators of compromise. Now, extending this, what we need to do is from the strings command itself, we need to add a parameter with that we want a little endian Unicode, basically strings, to be dumped as well. And we are piping it again to the same grep patterns, and let's see what comes up. Now when we pipe it, what we see is some command lines, commands, some URLs, some exes, some extensions, some PowerShell related stuff, and so on. So it may or may not be, again, the indicators of compromise. It's up to us to take a call onto it. Now, let's assume that we are going ahead with some of it as believing that it is an indicators of compromise. So what we'll do is we'll open a notepad, we'll copy some of it into it, and let's say gup.exe, and yeah, and let's say our normal one. So let's say these three are some of our keywords. Now what we are going to do is we are going to define a Yara rule. So what we need to do is create a rule file, and we'll say just rule1.yar, and here it starts with the keyword rule, and we are going to give the rule name followed by the open curly brace, and then define the string section. And here I'm going to define v1 as, let's say, the cmd /k, and then cd /d %. I'm giving the command complete line, but we just can ignore the complete command. We can just limit it to one keyword as well. I'm giving the $v2 as gup.exe, and I'm giving the third variable as a normal word. Now, if you remember, we got this not from a normal dump, but we got this from a Unicode parameter that we used with the strings command. So we want to use a wide parameter here as well. Similarly, wait a second, and similarly, if we see gup.exe, we didn't got on the normal sky one, but rather when we used the little endian support for the Unicode extraction of the strings, that's where we got gup.exe. So what we are going to do is we are going to edit this one again and add the wide character here as well. Now we are done with the strings command or the section. What we are going to do here is match the condition, and the condition that I'm giving here is all of them, and that's about it. So my rule is ready. Now what I need to do is we need to check whether this is working or not. So I'm going to use it with the Yara. I'm going to say print the strings wherever it matches, and whatever it matches, I'm going to do a recursive scan using rule1.yar in the current directory, and that's what we get. So we have a match rule on notepad++.exe, and this is the Unicode string that we got a match for, again gup.exe, and some of the words that we have got ahead on different locations. All right, now this is for the notepad++.exe. Now let's look at the second file that we have, which is satin.bin. So what we are going to do is we are going to run the same command again, which is strings. I want to extract the strings, which is Unicode encoded, from the satin.bin file, and I want to run the same patterns again. So we didn't get anything. So let's include the case insensitivity here, and what we see here is that this satin.bin is using the cryptographic algorithms. And what we can do now without the Unicode, let's see what the ASCII value tells us. And with this, what we get to see is that there are some encryption algorithms which are being used. There's a delete file process, there is a create process, open process, and these are all crypt related process which is based on the Mithray technique. These are prohibited, or these are considered to be the indicators of compromise. So we can say that this satin.bin indeed is one of the ransomware files. Additionally, what we can do is we can say SHA-256 sum of this satin.bin, and we have this hash. So what we can do is we can go on to the virus total and we can check for this hash as well, whether this is a malware or not. But that's for the separate video. For this video, what we are going to focus on is this. So let's again, copy some of the processes here, or the strings here. So delete file, let's say crypt create hash, and I'll keep it to crypt, and let's say open process, and let's take one more, which is this. And we are also going to take RSA and AES as another strings. Now remember, we have got the RSA and AES using the little endian encoding, and hence it's going to be the white character. So we are back to our rule file, which is rule1.yar. And here we are going to add another rule, which means you can have one file with multiple rules. And we are just saying it as satin rule strings. Again, we are just saying S1 as delete file W. That's what it says. We have S2 as crypt create hash, crypt create hash, and we have S3 as the open process. I'm just giving it as a case sensitive here, so that's okay. And then we are just saying as crypt, and here we can just say no case. And then S5 we are saying RSA and AES, and this is going to be the white character. And the condition is again all of them. And now let's run the rule again. So we have this command, we'll just copy and paste this. And what we see is the Saturn rule matches with the strings that we have provided, while those strings have not matched in notepad++.exe and vice versa as well. So this way you can scan for multiple files and you can get to see the matches and whether it's matching your indicators of compromise or not. Additionally, let's say if we want to give the file size, so our satin.bin is of around 185K. So what we can do is we can just say again, so in the condition, what we can say is that my file size is greater than, let's say, 180 KB. That's what I'm saying, and all of them. So which means that the file size should also match along with the strings. Now let's run the rule again. And here it is, it matches it again. Now since we have not given the file size in notepad++.exe, it doesn't really matter whether the file of notepad++exe is 100 KB or 10 KB or 1000 KB. So it really doesn't match, or it doesn't really matter there. But in satin.bin, it did match the size as well. So you see how easy it is to create Yara rules to match the indicators of compromise from the file. enjoyed this video, like, subscribe, and share. And please keep watching this space, this channel, for many such learning videos in the coming time. Thank you so much.